Hello everyone. I want to do a quick review of this week's lab. What this lab does is it will take a string, and in the script it will convert that string into a hidden image within an image. So essentially we want to edit the pixels of an image so it contains a secret message. Now, I understand trying to learn steganography, which is what this is called, along with the Python image library in a week is a bit much. So what I'm asking for in this lab is for you to perform one of the 3 steps this script does. The script loads up an image, and the first step is it resets all the pixels to a value of white in red, green, blue, and alpha. That would be 255, 255, 255, 255. So that will be your work this week. You will be writing the contents of a function reset image that will edit every pixel to the color white with full opacity. So the RGBA value of 255, 255, 255, 255. That might sound like a lot, but let's go over what this application does beyond that. After it loads up the image, after it resets every pixel to white, we take a secret message, and you can see on the screen here, I have a secret message that says, "Hello there, how are you? I want to tell you a secret." And the secret is, I am Batman. We take that message, and then we want to write it to the red channel, so the red color of every pixel in the image up until the end of the message. And then, just as we talked about in our conceptual video about steganography, where there is no more value of the string, so there's no more bits left, we write 255. So we convert a string, in this case the message I just said, to bits, ones and zeros, and then we walk through each pixel of the image. And in the red channel, if we have a bit 0, we write 0. If we have a bit 1, we write 1. And if we've run out of bits, we write 255. After we've written that image and saved it, and you don't have to write that, that code is there, then we want to run another function that reloads that image, reviews every pixel in the image in the red channel, and reads that message back to us. So if everything worked properly, we will write the message, and we go to read it back, we'll get the same message back. So all I'm asking for you to do in this lab is not to actually do the steganography work, but rather to write a function that clears every pixel and sets it to the color white. Now I have laid out some code in the reset image function, along with all the indentation to the solution. I've just left the solution out, but I've commented pretty much every line that you should write, and hopefully this gives you an idea of how it should be laid out. So you start off by opening up the image, and then you get the width and the height of the image, and then you write a nested loop statement. It's your choice which direction you want to go in. We talked about 2 different possibilities. So you can either have y on the outside of the loop and x on the inside, or x on the inside and y on the outside. And then for each pixel value, you get the current pixel value for an RGBA, so your red, green, blue, and alpha, or transparency. You print that value to the screen. You write the new value of the RGBA to the pixel. You print that new value to the screen. On these next lines, you'll want to iterate your counters, your X and Y counters, and then lastly, save the image file. Now, big hint on this lab. You'll want to read over the other code I wrote. So essentially, the only code you're writing is between these 2 comments that says edit code below this comment and edit code above this comment. And again, all your function does is walk through every pixel of the sample image and writes it to white. If you're wondering what to do, number 1, watch the videos. Number 2, read the chapter. 3, look at the other functions. So here we have read image from red channel. Now, we can walk through what this does. So essentially, let's go to the right one first. So what does the right one do? So essentially we take an image file, and I'll show you that image file in a minute. We open the image using Pillow in the Python image library, and then we grab the width and the height. These two lines magically correlate to the comments that I wrote in the method. So hint. Now this function is a little bit different. I take the message and I've written another function that converts that to bits. And just like in the video where I talked about creating a one-dimensional counter, this is the approach I took. So I created an overall counter, and then I did a nested loop where I iterate through every pixel. Hint, hint, that will help you in your function. Then I grab the RGBA value for that pixel, and I write the value to the screen. And then based on whether or not that bit is a 1 or a 0, or if we've run out of bits, I either write 1 or 0 or 255 to the red channel. I write to the screen the new value of the pixel, and I save the pixel using put pixel. I save the X and Y. I save the RGBA value. Hint, hint, you might want to be doing that. I increment X by 1. In the loop on the outside, I increment Y by 1. And finally, I save the file. So that's basically how I write the message to the image. And then when we want to read the message back, we do the same thing. Essentially, we have that double loop. And then I get the pixel. And then I say, okay, well, if it's not 255, it's either a 1 or a 0. I want to go ahead and save that to my message. And once I have hit a 255, if that else statement, now I know my message is over with, so I convert those bits back to a string and I return it. So essentially that's what we're doing down here, is we're resetting the image. That's what you're going to write. You're going to set every pixel in the image to 255, 255, 255, 255. And then I'm writing those messages to the screen. If you're curious on how I did string to bits and bits to string, that's at the very top. So let's see how this works. Now, number one, I told you use an image. Here's the solution file. There are two images in your labs. There's secretimage.png or ping, and there's secretimage.backup.ping. The backup file is there just in case you need you want to revert to the original. And the original is this. Let me open up in Paint, and we'll zoom into 800% here. And as you can see, it's just a bunch of junk. So what your function is going to do, it's going to turn this whole image white. So it's as if I had a paintbrush and I was turning everything white. The output of your function should turn the image into this. So from this to this. That's what your function does. And you're going to do that using Pillow, using the Python image library. So I'm not going to save that file, so don't save. And we're going to open up the command prompt. We're going to run the solution. So Python. Let me switch the directory. This would be week 7. There we go. Let me clear my screen, Python. So I'm going to run the solution file that I wrote, and it's going to do a lot of stuff. So I'm going to hit enter, and then I'll walk you through what it's doing in a second. So it was resetting each pixel. Now it's writing the message, and it read the message back. So essentially, what are we doing? I'm reading each pixel one by one. So first we call reset image. So I'm reading the pixel 0, 0. The original value was 237, 28, 36 with an alpha value of 255. And then I'm writing a new value to it, 255, 255, 255, 255. Okay, so that was x of 0, x0 equals 0, y equals 0. Now x equals 0, y equals 1. Now I'm taking the old values, 237, 28, 36, 255, and I'm writing the values 255, 255, 255, 255. So I'm doing this for every single pixel in the image. So that was step 1. All right, so that's reset image. Now, write message to red channel. What that's doing is it's taking the secret message, hello there, how are you? I want to tell you a secret, and the secret's that I am Batman. And it's reading every pixel and writing, so it converts this to bits, so ones and zeros. And then as you see here, editing pixel 0, 0, editing pixel 1, 0, 2, 0, and so on and so forth. It converted this to a message 1, 0, 0, 1, 0, 0, 0, 0, and it's writing that to every single pixel. And I'm just outputting to the screen just as an example so you can see what it's doing. And then finally, at the very end of the script, it reads back, reading the secret message, hello there, how are you? I want to tell you a secret, and the secret's that I'm Batman. So the message we write should equal the message we read, and it does. So what we've done is successfully written to the image and read back from the image. So how does this look? Let's go ahead and open what the image looks like when we're all done. And we're going to open with Paint. Again, we'll make this really, really big. So in some of the videos I talked about, when a red value is 0 and everything else is 255, essentially that's the color teal. Now, so what you can see here is all these bits, all these pixels are representing 1 bit in the red channel of this message. Now, looking at the screen right here, you probably can't tell anything's different, but I'm going to show you a little trick. So what we've done is, if it was a 0, the color value is 0 on the red channel, green 255, blue 255, alpha 255. If the bit was 1, the red channel bit is 1, the green is 255, the blue is 255, and the alpha is 255. And if there's no bits, if the message ended, like it does right here at pixel 24, 21, it shows a red value in the red channel of 255, a blue value of 255, a green value of 255, and alpha of 255, which shows up as the color white. Now we can use the paint bucket tool, and I'm just going to run the paint bucket right here and right here. And this is where you can see we actually have 2 different colors here. Paint will, when I do a paint bucket, fill the contiguous colors. So you can see each of these differences. I used black, and now we have teal, and each of these represents a different bit. So when you're seeing teal, you're seeing a 0, and when you're seeing black, you're seeing a 1 here. So I just wanted to throw that out there that we can, even though we used a 1 and 0 in the red channel, so to the naked eye it looks deceivingly close, we can use a paint bucket and throw it in there and show there is a difference. Now, when you did this in real life, you would take a picture of the Mona Lisa or a picture of space, and you would use a very detailed algorithm to encode these bits into the image so that anyone looking at it would have absolutely no idea that you were performing steganalysis. And you would take it a step further, and you would encrypt the text before you even place it in the image. So not only do you have the obscurity you're going to get of putting the message in the image, you're also encrypting it. So if you're wondering what this looks like, this is really what it looks like. So I'm not going to save this, and in the end there's also a backup file, but your goal here is to show me that you understand the Python image library. And you have a bunch of hints in this code file, in both the write and the read method, that you can look at to get some answers for this method or this function. And in doing so, you're going to learn a bit about steganography. So even though you're not writing those functions, I think it would be a bit overkill for a lab assignment for the week. In reading it and trying to understand it and trying to understand what parts you can put in your function to reset each of those bits to the color white, you're going to learn a little bit about how these functions work. So again, I encourage you to watch the videos for the week. Definitely read the chapters so you can learn the individual calls for the image library. So image.open, image.getPixel, image.putPixel, things such as that. Watch the videos, the conceptual videos definitely on essentially how the grid pattern works for an image, how to access XY, what the RGB values mean, and then watch the conceptual videos on these double two-dimensional nested loops, and also how to apply a one-dimensional array to a two-dimensional matrix. So just get started early this week if you can. Watch the videos, and good luck.